Hi everyone, this is the multi-stage air compressor tutorial discussion. So if you realize that I think there are 3 questions given for the multi-stage. So for the stage 1, for the first question, you will notice that the number is slightly different compared to the tutorial that I gave to you. So the first one is estimate the work done by 2-stage single acting air compressor to compress 3 meter cube air per minute at 1.05 bar and 10 Celsius to a final pressure 35, the intermediate receiver to cool the air to 30 and 5.6 bar pressure for air taken, assume the N is 1.4. So if you notice that my volume here is 2.8, but it doesn't matter. What matter here is the step, okay? You can also use your value is 3 meter cube to check out with the answer we're using the same step. So it's all right. So if you refer to the lecture notes, right? Okay, from 1 to 2, and then it will go to the 2 to 3, and then it will back to number 4, and then you go to further go up, all right, further go up 3 to 4, and you can see that there's a slightly error on the arrow. It's okay. So assume that the P1 and P2 is the low pressure cylinder. The P2 and P3 section is the high pressure cylinder. Okay, so we can use the simple basic equation to find the V2. So because amount of the volume go into from first low pressure to another, it should be the same, right? I mean the mass. Okay, it just change based on the pressure and the temperature. So by using PV over T equation, you can find the V2. So the V2 is this amount. Remember, this is per minute. Okay, and then if you look at this, there are 2 stages. So the first stages is P2 over P1. Okay, this one. And the second one is P5 over P2. Is it okay? So it seems like all the information given. Okay, if you check your lecture notes, the equation is given too. Check out later and plug in everything. I'm sure you can get an answer. It should be slightly higher than this, about 14.9 or 15, because I use yours is higher volume. Is it okay? So next move to the second question. The second question is a stage of 2-stage acting reciprocating air compressor draw in air at a pressure of 1 bar and 17 Celsius and compress it to a pressure of 60 bar. After compression in low pressure cylinder, the air is cooled at constant pressure 8 bar. So it seems like the P2 here or P3 here is 8 bar. At a temperature of 37, the low pressure cylinder has a diameter of 150 millimeter and the both stroke is 200 millimeter. If the low, so it means N equals to 1.3, find the power of the compressor when it's run 200 RPM. Okay, first we extract the information. Okay, we have the P1, we have the T1, and we know that it at the end of the pressure is 60, so which is P4 equals to P5, and the intermediate is P2 and P3, and T3 is the cooling part, so 37 change to Kelvin is 310, and it's given the diameter and the length, the stroke. So from there we can calculate the volume, right? So first we calculate the low pressure volume. So by using the cylinder equation, okay? And then from there, we can use P1 V1 equals to P2 V2 over T2, or you can use yeah. So and then you plug in all the information in, you can get your V2. Is that okay? Right. And then the work done, because this is two-stage, so we plug in all the information, the available information, we can get our work done. But now we need to find out the power. So the power is the work times the RPM. And don't forget, RPM is per minute. We need to change it into second. And therefore, you get your power. That's it. Okay? So next, estimate, oh, it's too fast. It's slightly too fast. Estimate the minimum work required to compress 1 kilo of air from 1 bar, 27 Celsius to 16 bar in 2 stages. If the law of compression is this, and the intercooler is perfect, so perfect means there are no changes, okay? For the temperature between the T2 and T8. Okay, so it's given that the mass is 1 kilo, the pressure, the temperature, the P3, the intermediate pressure. We know that the perfect intercooling, the intercooler pressure, you can find it within this. How? Please check it again in our lecture, recorded lecture. And then the minimum work required, because it's a perfect one, you can just times 2. The single times 2, because no energy loss. Then you can get your amount. That's it. It's quite pretty straightforward. I hope you understand it. Next, we will move to another tutorial. Check it out later.